So for law of cosines. Now, for section 2, law of cosines, what triangles, given information for a triangle, do you need in order to be able to implement law of cosines? Two sides in the angle, in other words, SAS, as well as 3 sides, SSS. Okay? You need to have those circumstances. Now, it doesn't matter. I honestly don't remember all 3 of these things. Just remember one of them. What matters here is that you have the same letter at the beginning and end, and then the other 2 letters are in between. Okay? It's actually a modification. It almost looks like a different version of the Pythagorean theorem, because it kind of is. Because if I had a Pythagorean theorem for this, what would be the B angle? 90. And what's cosine of 90? 0. So if this is 0, what happens to everything after the minus? Cancels, and guess what you got? Pythagorean theorem. Okay? The alternate version, honestly, I never really use it. You can if you want. It's one way to avoid a common error. Because what often students will do, especially when they're not given the angle, when you're trying to find the angle, is put everything on the right side together except for the cosine, and that ends up glitching things out a little bit. So I usually use this form anyway. If you really want to memorize that and use it, that's fine. So going down to here. Find the 3 angles of this triangle. So they're given side, side, side here. Now, to minimize rounding errors, I always try to find the biggest angle first. Where would the biggest angle be? C, because it's opposite the largest side. So I'm going to set this up where I have 12 squared is equal to 6 squared plus the 8 squared minus 2, 6, 8. Cosine of C. I don't know if you could see it. So from there, I kind of do this in chunks. Do the Pythagorean part, then deal with the excess. 6 squared plus 8 squared is going to give me what? 100. 2 times 6 times 8? 96. So you have 96 cosine of C. Now here's where students will often make a mistake, and I will have probably out of 94 students, I will have 2 make this error on the test. They will then subtract the 100 minus the 96. Why can I not do that? Yeah. 96 times the cosine means these are not like terms. Okay? So I need to do what with the 100?
Well, you subtract the 90 from 100, but you divide it.
Subtract it from both sides, yep. So when I subtract that, that's going to give me negative 44 is equal to negative 96 cosine, positive 44, getting ahead of myself, is equal to negative 96 cosine C. Then what?
What's the mistake people make?
They'll subtract these two from each other. So they'll have 144 equals 4 cosine C.
Because they'll be looking at it and they'll think that...
They'll just subtract these two numbers because they'll mentally completely separate out cosine from it. Okay? Just don't make that error. Divide by the negative 96, and I would just leave it as that fraction. Because then what would I do? Inverse cosine. So punch in inverse cosine. What do you get? Anybody else get that as well? Let's just call it 117.3 degrees. Now, do I have to use law of cosines for B and A then? No, I now have an angle I can work with, so you don't absolutely have to. Yeah, you can use law of sines to find the next one. So, which one would you want to find next? Doesn't really matter. I typically, just to keep it consistent, work from the largest down. So that keeps all your rounding errors grouped together, essentially. They'll only really badly affect the last number. And even then, it's not too bad. So I would actually solve for, what? B. The next largest one would be angle B, right?
Yeah.
Okay. So I'm going to set that up. Sine of B over 8 is equal to the one I just found, sine of 117.3 over 12. So you get B is equal to the inverse sine of what? It goes inside the parentheses.
117.3 times 8 divided by 12. Sine of 100.
There we go.
Times 8 divided by 12.
What do you get when you plug everything in?
I'm unsure of my
Point
answers.
five, a 0.592. That's what I got.
Well, then you have to do the inverse of it.
Oh,
I
yeah.
got
So it's
36.
I got 36.3.
Inverse sine.
Okay.
I was
36.3?
36.
Yeah.
Okay. Then what?
Then you add two together, subtract from one.
Yep. Subtract each of them from 180. Gives you what for A?
Uh,
26.4.
26.4 degrees. Not too bad. Now, SAS makes it even easier. When you have two sides in the included angle, how would I set up the law of cosines?
You have to have the second side of your equation.
A squared equals
B squared.
B squared.
Yeah, A squared equals. I would at least want you to write out the initial stage of it so that you can, honestly, it makes you less likely to make an error on it as well.
Well, capital.
Or since we know the number, 80.
Oh,
So then, that thing you can just plug in all at once. What do you end up getting for A squared?
Oh.
333.3?
That's what I got.
and then side A would be.
Yeah. Make sure you square root your previous answer. Don't just do 333.3 to avoid rounding as much as possible. So you get A is what?
18.25. Oh, 26.
Yeah, 18.3, 18.26, either one, if they don't specify. That would be the length of side A. Then to find the angles, what would I need to do? Law of sines. Set them up so you have sine of the 80 over the 18.26, and then each one of those is equal to sine of B or C over its respective opposite side. Questions on those two? Okay. Word problems, again, yes, you're going to have some. Softball game, a batter hits the ball to center field. The center fielder then throws the ball to third base. The distance from the center fielder to home plate is 240 feet. The distance between bases is 60 feet. How far did the center fielder throw the ball? What do you do?
Draw a picture.
Yeah, I would draw this one. What would you want to draw?
Well,
Most good.
Since from the center field is
Distance from center field to home plate.
softball.
Okay.
240. That'd be the straight up.
So straight up and down, that line would be the 240.
In between bases.
So where would I show the bases at?
Um,
They're 60 feet from home, but Probably. Hmm?
45 degree.
Why 45-degree angle?
It's a 90-degree angle between the bases. I guess.
Yeah, on a baseball diamond, it's actually not a diamond.
Softball diamond.
Or softball, whatever, same thing. Same thing for shape, just not size.
They tried to trick us.
Okay? So the idea is you have a square made out of the bases. So these are all right angles. This side here is the 240. How far is it from home to third? 60. And then what's the angle here? 45 degrees.
45, 45, 90.
No, that would give you a distance between second and third. I want to know how far the center fielder throws the ball to third. So this line's kind of extraneous for this problem.
So,
But now, what actually do you have?
you can find that angle that the person throws. So, 45 plus 90.
We have what?
SAS.
We have SAS. There's no need to find the other angles. I want this side. I have side, angle, and side. So, x squared is going to be equal to those two sides squared and added together. Minus 2. Go ahead and find the solution for this. Anybody else get that? So since we're talking about feet, I'd probably just go 202. Questions on that? Yeah, a lot of these ones, especially with law of cosines, the hard part's going to be setting up the triangle and not making errors there. So if they're being really nice to you and just handing you the values here, they got to make it a little more complex. Because this is talking about a ship.
Yes.
So describe the bearing from point B to point C.
What is a bearing?
Bearing's like north, some odd degrees, west, that kind of thing.
Due east.
Should be nautical there.
40 miles due east.
Could be. Doesn't have to be. So they give you the diagram for this one. 40 miles due east. If you didn't have the diagram, you could still generate it because you have all three sides. The three angles are locked. You just might get the flipped version of this because the only other place you could put C that would fulfill the requirements of these three distances would be down here. So you're going to get the right answer either way. It's just whether you're going to be, as far as the bearing, they'll just be a little bit off if you didn't have this drawing. Okay, so from here, what angle do I actually want to find on this triangle to start? B, because I want the bearing from B to C, so I need to figure out the angle at B. So how's well, obviously law of cosine, since we're in that section and have all three sides. What's going to be by itself?
B squared.
56 squared. Go ahead and find angle B. Anybody else get that?
Yep.
74.63 degrees.
That's not
That's not right, that either.
No, it's
I
not.
got 105.4.
Oh wait, why am I so stupid? I don't know.
What caused you to get 74.63?
They done messed up.
I messed up.
Yeah, but how?
Negatives.
A negative sign.
Oh Jesus.
Uh,
Oh yeah.
Because you're dividing by negative, you drop off the negative.
Ooh.
Yep. 105.4 degrees for that. Now, is that my answer?
No.
No. How do I actually find the bearing from B to C?
subtract 90.
Subtract 90. The idea is, if I drew a compass rose here, north, south, east, west, this part of the angle is going to be 90. What I actually want is how far off of north it is. So yeah, you're going to have 15.4 degrees. And then what letters am I going to have around it?
East of north.
East of north, so north 15.4 degrees east.
East.
Questions? Yeah, you can't do like 12 degrees north of east. It always goes from north and south. Okay. One more thing. We have another area formula.
What is
This
this?
is Huron's area formula. Actually has two parts to it. Because you first must find this S value. Now the S is what you get when you take the product or the sum of the three known sides of a triangle divided by 2. Then you do the square root of that S value you found and then the difference of each side compared to it. Okay? And if it says solve by Huron's formula, yes, you do need to do it. Plus, honestly, it's not that bad. Because if I have a triangle with these three sides, first thing I need to find is that S value. All you do is sum the sides and divide by 2. That gives you what? 11. Then, for the actual area, I'm going to do the square root of 11 times the difference for all three sides.
We did this last year.
FS and T usually don't. Plus, you might talk about it
Plus stuff.
as one part of one lesson. What do you get for the other three numbers?
19.9.
You get 6, then what?
I did it all at once. 2,
3. Now, the problem is if they ask for exact answer, you're taking 11 minus each one of these values. Taking that S value minus each one of those. Now, the nice thing is, it's almost set up for prime factorization already. What do you see that repeats inside the square root?
3. 2.
So together you get 6. You have 2 6s up there, right? So essentially I can just pull 6 out and you get 6 root 11 if they're asking for exact. Or as a decimal, what do you get?
19.9.
19.9. What would be your units?
Feet. Square.
Square feet.
Feet squared.
Square.
Questions on any of it? Okay. Rest of the time is yours.